Welcome to the Explainer. Today, we're digging into something really cool. How do we give artificial intelligence a better memory? And I don't just mean storing more facts. I'm talking about the ability to actually learn from the past, just like we do. So let's start with a really fundamental question, right? When you or I make a mistake, we feel it, we remember it, and hopefully we learn not to do it again. But for most AIs out there, well, it's just not that simple. Their memory doesn't really work that way at all. And this right here is the heart of the problem. AIs often treat their memory like a giant digital shoebox, where every single thing that happens, the good, the bad, the useless, it all just gets tossed in. They're storing a ton of data, but they aren't necessarily learning from it. There's a huge difference. This brings us to the core of the issue, a concept that researchers call passive accumulation. So what on earth is passive accumulation? Well, imagine your brain was a notebook where you wrote down everything that ever happened, but you could never rip out a page or even just highlight the important stuff. Pretty soon, it would become this messy, chaotic jumble of good ideas, bad ideas, and just plain noise, making it almost impossible to find the right lesson when you really need it. That's the challenge for so many AIs today. And check out this perfect real-world example. It makes it super clear. On the left, you've got an AI that's told to buy a stock at the prevailing market price. With no useful experience to go on, it literally just makes up a price, $190.50, and of course, it fails. But the agent on the right, it has a proper memory. It remembers a past lesson. Hey, first, I need to use a tool to get the real-time price. It does that, finds the price is actually $227.16, and then it places the order. Simple, but absolutely crucial. So if passive accumulation is the problem, what's the solution? Well, researchers have come up with a brand new framework called ReMe, and it's designed to give AI an active, evolving memory. ReMem, which stands for Remember Me, Refine Me, a great name, by the way, is designed to completely transform AI memory. We're talking about going from that static, messy shoebox to a dynamic, thinking tool. It's not just about remembering anymore, it's about refining what you remember. So how does this whole thing actually work? ReMe operates on this continuous, three-phase life cycle that allows an AI to constantly get better and better. It all boils down to these three key steps, and we're going to break them down. First, the AI acquires knowledge. Then, it learns how to reuse that knowledge for totally new situations. And finally, and this is so important, it constantly refines its memory. Think of it like a self-editing brain. Let's start with that first phase, acquire. This is where the real magic happens. See, ReMe doesn't just save the whole event. It actually analyzes what happened, looking for patterns in its successes and the specific triggers that caused failures. And what's really brilliant is that it even compares the two to pinpoint the exact decision that made all the difference. It's distilling the lesson, not just the raw data. Okay, next up is reuse. Because what good is having a great memory if you can't find the right information at the right time, right? ReMe is designed to sift through its past experiences and find the most relevant one for whatever new task it's facing. And it's not just a simple copy and paste job, it actually rewrites and adapts that old memory to fit the new context. And then we get to the final and maybe the most critical step, refine. You know, just like us, an AI needs to be able to forget things that are no longer useful. ReMe is constantly cleaning up its own memory. It adds new, successful experiences, for sure, but it also keeps track of how often an old memory is actually helpful. And if a memory just isn't useful anymore, ReMe gets rid of it. It prunes it away, keeping the memory pool lean, sharp, and effective. But the big question is, does all this complex engineering actually work? I mean, do these AI agents really get better at their jobs? The results are kind of shocking, actually. So take a look at this chart. It's fascinating. On the left, we've got a really big AI model, 14 billion parameters. You can think of parameters as just a measure of its raw power. It gets a pass rate of about 54.6%. Now, look at the bar on the right. This is a smaller model, only 8 billion parameters, but it's been given the ReMe memory system. And look at that, it actually outperforms the bigger model. In fact, giving that smaller model the ReMe framework boosted its average performance by a massive 8.83%. This proves that having a better, smarter memory can be way more important than just having more raw computing power. It's not about being bigger, it's about being smarter. And this is the key takeaway, said perfectly by the researchers themselves. Memory quality can substitute for model scale. This points to a whole new, much more efficient way to build smarter AI. So let's zoom out for a second and just think about what a breakthrough like this means for the future of artificial intelligence. So why does all this matter to you and me? Well, for one, it means AIs can learn and get better on their own without these incredibly expensive and time-consuming retraining sessions. It's a much more efficient path to creating smarter AI agents. And maybe the most exciting part, it starts to shift AI from being just a static tool to becoming a true lifelong learner that evolves with every single thing it does. Which leaves us with this final, really exciting thought to chew on. If an AI can genuinely learn from its wins and its losses, pruning away bad habits and reinforcing good ones, all by itself, what on earth will they learn to do next? Thanks for joining us on The Explainer.